Hello everyone, my name is Rajesh Kumar and I'm your DevOps SRE DevSecOps coach. Okay, so today I'm going to teach you starting with Linux, then here Linux internal actually. Okay, Linux internal, and then after that we'll move on to Vagrant, and before that VirtualBox. Okay, so Linux internal, VirtualBox, and then Linux command. Here I'm going to take one session for it, and Vagrant, and one more which is batch scripting. Okay, so this is something which I'm going to help you today. Okay, so let's get started with Linux internal. Let me open up my slides.
Quick question. These slides, are they online?
Yeah, on the I'll share the location with you. Okay.
Hi, is this the first class? Or
Yeah,
I'm not
it's
sure.
a first class. First class.
Okay.
Okay, so let's get started. Linux kernel internal. So what is kernel? So basically, Linux, when we say, is a operating system. An operating system, you have a multiple components, and most important component which we have is kernel. So what is kernel? So kernel is like a kind of program which has been written in C language, and this program is basically for converting our languages to machine language so machine can understand, and machine language to our language so I can understand. It's like a translator kind of, because we understand, let's say A, B, C, D, E, F, something like that, but kernel understands, I mean, machine understands 0 and 1. So this translation is done by kernel and many other tasks also. So kernel is a computer program at the core of the computer operating system and generally has complete control over everything in the system. Okay, so if you see that here, uh, you have some software which is a user level software. User level software means you can say browser or something like that, or maybe notepad, or maybe console and many other stuff. And we have a kernel, and then kernel talk to the hardware, CPU, memory, disk, and devices. So where kernel program runs, so it is a portion of the operating system code that is always resident in the memory. Mind it, kernel program always resident in the memory and facilitate interaction between hardware and software component. So what happens when you boot the system, a kernel get loaded in the memory and always there until you shut down, and this only facilitate your all this work. So when the kernel program run, the kernel is one of the first program loaded on the startup. When you start the system, after the bootloader, kernel programs get loaded. So there are different types of kernel available. We have microkernels, monolithic kernels, hybrid kernel, nano kernel, exokernels. So we are using most of the time monolithic kernel. In fact, your Android is a kernel actually. Okay, mind it. Android is also Linux kernel. So what are the primary roles of kernel? I mean, what are the work is been done? So more or less it's doing everything. For example, task management. So whatever the task you give it, let's say opening a browser, opening a notepad, or you know, anything you want to run a certain applications. So it is managing your task management. You might have seen it here also. Here, this is a task manager, right? So right now in my laptop, these are the tasks which I'm running right now. Look at this, pretty huge. I have not rebooted my system from last few days. So many tasks are there. These are all our applications actually. If you see, it's running actually. So these are the task manager management. Device input and output management. That means your hard disk is connected to your system, RAM, CPU, mouse, keyboard, and all stuff like that. So they manage this also. Interrupts and event handling, whatever you do in the system, that is also. Timer management also, memory management, sync and communication. So these are the primary tasks of role of kernel, which they are doing it. Okay. So a full kernel control all hardware resources. Example, input, output, memory, cryptography via devices driver, arbitrage, conflict between processes, versioning such as CPU, file system, network, memory, peripheral devices, and all. So that is a primary role. Anyone have idea who's this guy?
This is BizDevOps.
Yeah. So his name is Linus Torvald. He's the father of Linux. So he has written the Linux. So yeah, Linux kernel is the free and open source monolithic modular multitasking Unix-like operating system kernel. Okay, so it was originally authored in 1991 by Linus Torvalds for his i386 based PC, and soon it got adopted to many other domain also. So yeah, where can you use the Linux? So everywhere. Simple answer. Everywhere. Linux is the only one operating system which you can use everywhere. In fact, Android you have a Linux. Supercomputers also there are use the Linux. So now, what is a bootloader? So when you start your system, any server, when you start your server, bootloader, also spelled as a bootloader or boot manager or bootstrap loader. It is a computer program, again is a program that is responsible for booting a computer. So when you start the computer, this program runs, and this basically decide what you want to boot with, booting devices. Okay. So when a computer is turned off, its software including operating system, application code data remains stored in the non-volatile memory. When a computer is powered on, it typically does not have an operating system and is loaded or is loaded in random access memory. The computer first execute a relatively small program stored in a read-only memory, that's called ROM, and later EEPROM and NOR flash, along with some needed data and stuff like that. So this is the first program which get loaded when you start the computer, and then it load the your kernel. So look at this here. When you power on, ROM code get loaded, then it call the booting devices like your storage or whatever it is, and then bootloader loaded the kernel, and then accordingly it happens. So power on, load bootloader in ROM, and load kernel code in RAM. This is something which happens. So kernel code runs in a RAM. Remember that. Some of the image I'll just ignore it. Yeah. Now in a computer you see the two space. What is this space? So basically this space is nothing, it's a logical unit, not a physical unit. It's a logical unit. So there is a two space, kernel space and user space, and you need to remember this all the time. Okay, kernel space and user space. So what is kernel space? So what happens? Anything you do in the operating system, okay, anything you do or kernel is doing it, they are divided into two part. One is a kernel space and another one is user space. Okay, all the tasks either they run in the user space or kernel space. So computer OS usually segregates the virtual memory which you have, into user space and kernel space. Okay, now the kernel perform its tasks. The kernel is the same thing which we are discussing. Kernel perform its tasks such as running processes, managing hardware devices such as hard disk, and handling interrupt, and in this protected kernel space. Okay, so kernel, whatever the task it is doing, discuss what are some of the tasks they are doing in a kernel space, and it is protected. Okay, protected from the user. But you, whatever you do, user space, you do, you log into the system as a Rajesh, and then you start doing something. For example, browser, notepad, some applications you run. So you start doing something, and those things are running in a user space. Okay, but kernels, any application which is running in the kernel space is protected. For what? We'll discuss this one. So there are two space. Remember that. So what is the use of user space and kernel space? So we understood that all the kernel programs we run in the kernel space, all the user programs you run in the user space. So why do we have this mechanism? Why this all the program is not running at one space instead of two space? So there are reason for it. What happens? You, if you are running the all the program in kernel space, you means user, then there is a chances like you will spoil the kernel and make it destabilized. Instability, you'll cause the instability. That means maybe you are running some viruses, maybe you are running some sort of bad code, bad programs, which will interrupt the kernel. And if kernel is interrupted, then your system will not function properly. So what is happening here is all the tasks, all the processes which are required to run the operating system is run in a kernel space to provide memory protection and hardware protection from malicious and irrelevant software behavior. So this separation prevents user data and kernel data from interfering with each other and causing instability and slowness. Okay, as well as preventing malfunctioning application from affecting each other or crashing the entire operating system. So here you see that we have a kernel space which runs in supervisor mode and has access to the user section as well. So kernel space has access to user space, but both are separate space. The kernel memory map is fixed. So here if you see the kernel and then user, and here if you see supervisor mode, which is managing and accessing all the kernel, accessing the user space also. Okay, so that is important. That is important. Okay, so now the question is, there are certain applications kernel is running, of course, and there are certain application users are running. So user need to get the CPU access and RAM access and device access. I mean user space application, the application which you're running in the user space, need to have CPU, RAM, device, and many other access of the hardware. So how users application which is running in the user space can get the access of this? So that is where we make a system calls. This is a very important question. Okay, this is a very important question, and this is an interview question also. Syscall, we call it a syscall, full form system calls. So how the process is running in the user space is getting the access of kernel space. When I say kernel space means all the kernel space resources like the hardware and CPU, RAM, permissions, and all stuff like that. So how do we get it? So this process we call it a system calls. Okay, so all the users application which you are running processes is getting through the system syscall accessing the kernel space. So you see that here in the user space you run bash. So bash is asking get PID. So PID is managed by kernel space. User ID is managed by kernel space. Network is managed by kernel space, but all the application is which is running in user space is accessing all the resources. Okay. Again, you see that there's one file you run one application cat, and you wanted to open this file. So now the method which is being used open, and then again some files, some your hardware VPS, XFX, block devices, your storage you are accessing it, and that between the user space and kernel space the syscall happen, and the syscall has a multiple method actually. Are you understanding, all of you?
Yes.
Are you understanding? Okay, so look at this one more visualization. So you have a hardware, and then top of the kernel run all the system interface, generic services, device driver, and all, and kernel space, and then you see that you have a user space, some program you run, and then program using the syscall you access the kernel space. Okay, so here this is a beautiful write-up which you can refer it. The Linux kernel has millions of lines of code. Kernel read plus write files, decide which programs get to use the CPU, and make the keyword work. I mean, everything is done by kernel. But if you look at this again, next block, when Linux kernel code runs, that's called kernel space. And when your program runs, that's called user space. Okay, so whatever you do in user space. Okay, now because user space any program you're running you need access to CPU and all other stuff resources, then what you do? Okay, third block, time to write a file. So users wants to write a file, that's my job. So what will happen? That is where your program, the one which you are running in the user space, switches the context and send the request to the kernel space. Okay, so again your program switches back and forth, str, mystring, x, whatever the program you write and all this thing, switch to kernel space, you got the response, and we are back to the user space. So this is keep on happening actually, but you think like everything is happening like that, so it must be time consuming. No, you know that experience already of the compute, so it's not taking too much of time. Timing your process, if you want to time your process, you have all this stuff. Okay, so now we have understood the concept of user space and kernel space and hardware. This is a little bit detailed image, I'll just ignore it. So in terms of architecture, yes, we have a hardware. On top of we have kernel, which where we have a kernel space running all the program. Then we have a shell, and then we have a lots of companion utility. So this image is something which you might have seen so many times while studying engineering and all kind of things. Okay, so here this is also one good image. Look at it very carefully. Hardware, then we have a kernel, and here you have kernel space and then top user space. And if you see that here, all the applications which is running in the user space is calling the resources of kernel using syscall interface, which I said. So all of you are comfortable by this concept by now? Any questions?
No as such.
Okay, so let's move on. I'll just ignore that. Some of the things I'm ignoring it because we don't need to go into deep right now. Just hmm. So processes and threads. So if you're talking about processes and thread, I'm talking about this one. This is the process which you see here. These are the complete processes which is running in my laptop. So what is a process and what is a thread? This we need to understand. So what is a process? So look at this here in this image. You see there's one process, and that process you have a multiple thread. Here also you see in this image little bit elaborated. Processes getting the CPU and then passing to the threads, right? So what is process? So process is a computer program under execution. That means any program which is in running mode, okay, that's create a process. If the program is not running, that means that process has been completed. It has created a process, but this has been completed. Okay, so some processes you just, for example, running, for example, I'll tell you, go to command line and here you run dir. So I just run this dir. It's created one process, but it disappeared also because the job is done. Okay, I run cls, job is done. So this created a temporary process. Some processes which is keep on running. For example, you can see that these are all running processes. Okay, so processes is a computer program under execution. Linux running many processes at given time. We can monitor them on a terminal, which I showed you in Windows. Linux, we have a ps command actually. Okay, so Linux processes are isolated and do not interrupt each other execution. Mind it, each Linux processes are isolated and it has no relationship with each other. Do not interrupt each other executions. So process with the PID, we can identify any process in Linux. Internally, the kernel uniquely allocate this number and release used for reuse after the process exit. So here, each processes you run, each processes you run, you get a PID. Here you see the PID. Kernel allocate this PID, okay, and using that we can identify, okay, this is the process. Okay, now if you look at this here little carefully, So these are the processes, number of process running in my system. Let's say this is the Chrome, okay, and the PID allocation for this is 280. And if you see that this is running in the user space, which is Rajesh Kumar, and here how much memory you are being using it, this is the one, okay. So it should be CPU also. It's here. So CPU also, it's not using it. Chrome, I'm not using it, means it's running, but I'm not firing any commands. So in order to run any program, mind it, just RAM is required, only RAM, okay. But in order to use that, when you use the program, you start firing the command, that is where the CPU is required. So you see that most of the CPU is 0. So let me show you that which are the CPU right now is being used. So look at this here. I'm running GoToMeeting right now, and we all are connected to the GoToMeeting. So it's required the CPU. I'm using it right now. Okay. So you require the CPU, but the program which we are not using it, so it just required memory for running it. Okay. So now this PID got attached to this user, this CPU, this RAM, and some access also. So who's doing it? Kernel. So yes, process with the PID, we can identify any process in Linux. Internally, the kernel uniquely allocates this number and release it after the use, after the process exist. So now just let's say I run ls dir. So this created one process, but it cleared from here also. Why? Because it was a short-lived process. The moment that you exit the process, that PID will release to reuse by other process. That is the job of kernel. So since many processes are running at any given time in Linux, they have to share the CPU. The process of switching between two executing process on the CPU is called process context switching. This is important. I'll tell you one thing. There is a one concept which you call the your software is running. I'll put it in a very simple way. And the software you are using it, there is a difference. For running it, just a memory is required. For using it, you need a CPU. But the problem is system cannot assign CPU. System cannot assign CPU at parallel. That is a problem. Okay. So system, we feel we are running the application parallel, but in reality, it is not. So that's the reason you see that if you notice carefully, all the processes is having 0 CPU and only one or two is changing. If you notice, are you able to notice this one, this place here? Hello?
Yeah, yeah.
Hmm. So at a time, kernel will allocate the CPU only to one process, only to one process. Okay. And you see that reality here somewhere, except the system idle process, just ignore it. So this process, we call it process context switching. Okay. So process context switching is expensive because the kernel has to save old registers and load current registers, memory map, and other resources. What I'm saying is, what happens? Let's say here there is a two process, D D DMW, DWM, and go to.exe. So now what is happening? Uh, I'm using GoToMeeting also. I'm using DMW, some background process is running network or something. That is also running. So system has to allocate the CPU to both the process because both are in use actually happily. So if you allocate the CPU to, let's say, GoToMeeting, go to.exe, then DMW, whatever the activity was done, it has to be stored. and then whatever I do in the go-to meeting, it has to be stored. It happens so fast. Right now, you are not able to see that so fast, but it's happening very fast. Okay, so this process is called process context switching, but this is costly because in order to save the registered and all the details what you did in the last session, in the DMW session and go-to meeting session, it required time also, and then um, it delay the step also. So in order to fix this problem, so in order to fix this expensive process context switching, we have got the concept of thread. Okay, thread. Okay, so now you see that here, this is the same thread I'm talking about. So see here, you have a process, multiple thread. Okay, so here you have a CPU, process, thread. So we have a thread. So now what is thread? So thread is a kind of lightweight process itself, very lightweight compared to process. A process can do more than one unit of work concurrently. That means more than one work by creating one or more threads. Okay, these threads being a lightweight can be spawned quickly. Okay, so in order to save the expensive context switching, process usually what they do, they created thread. Okay, so what is the advantage of thread? So I'll discuss about it, but if you want to understand this, how can you see the thread in Linux? So you can run the command ps-elf and then look at the column PID and then LWP and NLWP. Okay, so PID, which is a unique process identifier. LWP is unique thread identifier inside a process. Mind it, inside a process. So inside a process, you can have a multiple thread. And this column will tell you how many thread you have given for the process. That column which you call it NLWP. Just look at it during offline. Here is the example. So see here, LWP, NWP. So if you see my cursor, follow my cursor. Here you have a LWP and here NLWP. You see multiple threads are there. For modem manager, multiple threads are there here. 4. So process can have a process is like a process. Thread is like a process only, but it's a lightweight process. A process can have a multiple thread. Okay, and this thread can spawn quickly, and how many threads we have and processes, you can check it out through this. Okay, so now single threaded process, that means there is a one process, we have a single thread or multi-threaded process. Okay, there's a two kind of process we have, single threaded and multi-threaded. So any thread created within a process share the same memory and resources of the process. In a single threaded process, the process and threads are the same. Mind it, are the same, as there's only one thing happening. In the multi-threaded processes, you have a multiple thread and you keep spawning the new thread as you need it within the same process, so it's become cheap. Why is become cheap? So you don't have to switch the processes. Okay, context process switching is not a problem here because you are not switching, it's the same process. So here in a multi-threaded process, the process has more than one thread, such as process accomplish multiple tasks simultaneously or almost at the same time. So let me put it in this way. Let's say you open up a browser. Okay, and you want to open up a multiple tabs into it. So when you open up a browser, it is creating one process because you are using it. It required a CPU. Now, when you create a multiple tab, when you are downloading some files, in another tab, you are streaming some videos, other tab you are browsing. So all these are the thread, can be thread. So because this thread are a part of the same process, it is much faster and you can save CPU for that. So any CPU assigned to the processes, all the thread, any CPU assigned to the processes, all the thread are consuming the same CPU, share the CPU. Okay, so that is something. So thread also can switch faster since they have shared address space with the process compared to the processes in the CPU. Internally, the thread has only a stake in the memory and they share the heap process memory with the parent process. Okay, so look at this here. One process, you have lots of registers, stack, data, files, code, and all everything. And here you have a single thread. Here you see that here you have all these resources and multi-thread, and they are sharing the resources like that. Okay, so few things which is there, I'll just not confuse you with the too many things. Yeah, so this slides, I think we should refer it. So this is an interview question and very important if you're preparing for an interview. What is the difference between process and thread? So process is a lightweight, a thread is a process is a heavyweight, a thread is a lightweight process, also called an LWP. A process has its own memory. A thread share the memory with the parent process and other threads within the process. Mind it, all the all the threads sharing the memory which is assigned to process. Here, when we have processes, inter-process communication is slower due to isolated memory because each process has its own memory. When one process shift to another process, I just said you have to store the last what you did. Okay, so it is expensive, it a little slow down the system. So that is there, and that problem is solved in the thread. So inter-threaded communication is faster due to the shared memory. Here context switching between the process is expensive due to saving old and loading new process memory and second sorry. Here context switching between the thread and is less expensive due to the shared memory. That is the difference. Okay. An application with several processes for its component can provide better memory utilization when memory is scarce. We can assign low priority inactive processes to in the application. The ideal process is the then eligible to be spot to the disk. This keeps the active component of the application responsive. When memory is scarce, the multi-threaded application does not provide any provision to manage memory. So these are the difference which you have between the process and thread. Again, one more time, process typically independent, has considerable more state information than thread. Separate address spaces interact only with the system IPC. Thread subset of the process, multiple threads within the process share process data, process state, memory. Threads share their address space. So this is something which you have to understand. So any questions so far? Any question?
No.
Okay. So we have a few other components also, like a scheduler or process scheduler, which basically schedule the tasks. And in Linux, preemptions we have, which is the theory behind the task scheduling is very simple. If there is a runnable process in the system, at least one process must always be running. If there are more runnable process than processes in a system, not all processes can be running all at a time. So there is a one concept which you call it preemption, a forced suspension for the process is called preemption. All Unix flavor have been providing preemption multitasking since the beginning. Then the concurrency, how this multiple instructions run at the same time. So Linux has been awarded with the concurrency also. Synchronization between the process. So this one module is there in the kernel, which will help you to sync between the multiple process. So this is something which we have. Okay, so let's summarize this discussion. So what we understood is, let me write it. What we understood is Linux is operating system, which we all know. Operating system powered by kernel. Okay. Kernel is nothing but a program. We have a different types of programs which we have. I will not tell you that this type of program right now, but in Docker session, because we need to know this types of program. It's a huge sort of program. This basically kernel manages hardware, okay, all the processes, all the sync and devices and everything, memory, CPU, RAM, and all the device driver, many things it manages. All this thing kernel manages in the kernel space. Okay. Now you user, all this application what you run in the user space. Okay. Now user space, the application which you are running required a CPU, memories, and storage. Okay. So how does user space application talk to the kernel space? How?
This is a syscall.
Syscall. Yes, this is an interview question. I'm stressing multiple times. Okay, so they will tell you how this user application interact with the kernel space, getting a resources. So you should say there is a application which is running in the user space for virtual memories. There is an application which is running in the kernel space by kernel. If you want the resources like CPU, RAM, storage, and blah 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 blah, then application which is running in user space make a call to kernel space using syscall, get the resources and getting done. So here in user space, in fact, everything is running in the system, running as a process. Okay, process means a runnable exit runnable code which you are running, which can run and exit or keep running, depends on the types of application. So process is a kind of way where you can ask a CPU for running the applications in a way. Now multiple threads can be there, depends on your applications actually. Multiple threads can be there, single threaded, multi-threaded, and this is how it works. Okay, so I think we are done with this introduction of Linux kernel. Just keep in mind whatever I taught you only. More things again, those who have an interest, you can get it into that. What are the different types of program we have in kernel, that I'll talk about in Docker session, because that is where you need to know. So what is sorry. So what is VirtualBox? So VirtualBox is a one hypervisor. Okay, so here if you see, it's a hypervisor. So what is hypervisor? Anyone have idea what is hypervisor? Anyone?
Basically, this is to convert physical to logical. Uh,
Mhm. So hypervisor is like this. Here you have a hardware, and then top of that we have kernel.
Like on the base machine,
Okay,
we are installing hypervisor.
what is that? Yeah. So here you have hypervisor. Sorry, hardware, and here you have a kernel, and then kernel on top of that you have a users, multiple users. So this is the, we call it a physical server, right? So so can we run multiple kernel in the same machines for multiple isolations, multiple operating system? So what we do typically, we have hardware, and then we have a top of that we have a kernel, and on top of that we have a one software which is called hardware. So mind it, this is hardware, and then kernel we have, and then one software is there called hypervisor. This software is called, is a category of software, it's not a software, hypervisor. And on hypervisor we create a VM, virtual machines, one virtual machines, two virtual machines, three virtual machines. And after that, inside of virtual machines, we have a kernel again. This is a Linux kernel, this is Windows kernel, and this is Mac kernel. So here you see kernel you have separate kernel, and then user and stuff like that. So here you see that this kernel can be Windows also, Linux also, Mac also. So now you saw that these three machines I created one different operating system, different using the hypervisor. So hypervisor is like, we call it a virtualized software which will help you to create a virtual machine. This is virtual machines. This is a machine which I showed you, one machine, one server, physical machine, but now this is a virtual machines. And now this can be done, this can be created using hypervisor. Understood all of you? All of you?
Yes.
So now you want to know the list of hypervisor? See here, these are the one. Hyper-V from Microsoft, VirtualBox from Oracle, I'm teaching you the same one. KVM, Zen, VMware XIs. VMware has multiple solution for it. Citrix system, QEMU, Red Hat virtualizations also. So many other are there. Look at this. Many are there. LXCs are there and stuff like that. So using this software, you can create a virtual machine on a physical server. So I'm teaching you VirtualBox. Okay. So in fact, AWS you see, or Azure, they're also running certain hypervisor, customized one, where using that hypervisor through website, you can create a virtual machine only. Okay. On AWS, you have virtual machine. Google Cloud, you have it. Azure, you have it, and all stuff like that. Okay. So now you understood that what is this virtual machine?
Yes.
Any questions? Okay. So now why I'm teaching you VirtualBox, one of hypervisor which you saw here. Why I'm teaching you one of which? So you should create your own environment in your laptop itself. Okay, you during the DevOps operations, you will come across many software, okay, many things, and that you wants to set up in your machine itself, laptop itself. No need to go to AWS, no need to go to Azure, but in your laptop only, which you can use it anytime wherever you want. So this is the hypervisor. So here the first question is how to download. So how to download. So this, just put it in Google and you see here you need to download this one. If you're on Mac, check your motherboard, I mean CPU, and this one. Linux we have here, and so on. So this is the how to download VirtualBox. You will download this software, and after that is executable, you will install it. Next, 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 and finish. So once you install it, you will open up this one here. Okay, look at this. So mine is 7. Mine is little older, I guess. That's the reason its pop-up is outdated, but it's okay. Now you see the left side, I have so many virtual machines. Dynatrace, New Relic, Artifactory, Grafana.
Hello.
Yeah,
I think there is some voice issue actually. I'm just losing a voice in between quite a lot. Is it happening for everyone? I don't know.
is it happening for everyone?
No.
Okay, Tushar, you can rejoin. Probably it will fix that issue. Okay. So now you see that left side, you have so many virtual box. This virtual machine, I have it. You see Ubuntu here, Windows also will be here. So many. So you can create your own virtual machines. So after installing it, you'll have to create a virtual machine. I'll show you how. But before creating a virtual machine, you need a virtual image. So what operating system you want to learn? Again, depends on you. So here you can decide CentOS, you can divide Ubuntu, whichever you are comfortable, go for it. So Ubuntu is easy to work compared to CentOS and so on. So Ubuntu, you can go for downloading 22. Right now we have 24, I guess, 23, I guess. So just go to here, Google, and download Ubuntu image. Just write Ubuntu image, and you see that here desktop. Don't use desktop. Desktop you have a UI just like a Windows, right? Same way. So click on this one, server version. You go for it. This is 22. Download it, and the files will be around 4 GB. So let me show you the files so you'll get comfortable with it. Here, see here, I have downloaded few images. So this is the Ubuntu. This is CentOS ISO image. Okay, so this is you will download it offline. CentOS image, if you want to download CentOS 7, CentOS 8, download. It is the latest one. Okay, this is the one. See here, this is CentOS 7. I think here you have 8 and 9. Go for 7 also. That is more than sufficient. Okay, so this is the VM. So you'll download it and keep it ready locally. Are you comfortable, all of you?
After downloading, we need to install it, or it is just download. So
No, first step number 1, download VirtualBox. Step number 2, install VirtualBox. Step number 3, download image, Ubuntu or something. Step number 4, create VM. This I'll teach you now. Are you comfortable now? All of you?
Yes.
Okay, so let me create a VM now. So here I'm going to create a VM, Windows or Linux, of course Linux. So Ubuntu for what? Demo. This is the name of the VM. It will be stored here. Let it be Linux or what exactly? So Linux. What kind of Linux? What version of Linux? So I'll go for Ubuntu 60. The moment you type here, no, automatically it's selected here actually. Next, the VM, how much memory you want to give it? So right now, my laptop have 16 GB. So I'm okay 4 GB, 6 GB, up to 8 GB also you can give it. So 4 GB I'm giving it. You can also do the like a 2 VMs you create, 3 GB, 3 GB, something like that each. So this much of memory you have given. Next, create a virtual hard disk now. VDI, what type of hard disk you want to create? VDI, VHD, VMDK. Now offline you can study what is a VDI, VHD and VMDK, but right now whatever is coming with the default, don't change it. Next, the size of the disk should be dynamically allocated or fixed size. I'll go for the dynamically, that way the storage you will not have a problem. How much of disk size? So here I'll make it 30 GB minimum for the any installations and all. Create. So this VM has been created. Now we have to feed the operating system into it. So just like this, I did it for Ubuntu. You can do for the rest of the things, same steps, Windows or whatever it is, or RHEL CentOS. Make sense, all of you? All of you?
Yes.
So now what I will do, I'll click on the setting and go to the storage. It will be in the recording, so you can do at the little pace, slower pace. Under the storing, there is one option called empty. Click on it. And here there's one disk option. Click on it. Because I have used this ISO image which I downloaded earlier already, so you can see in the screen here, but you can browse also. And this is the one, which one you want to install? So I'll go for this one, Ubuntu 2004 dot dot dot. Open. Okay. So I set this ISO image for this, and then start. Now it's starting. I'll have to have a patience little bit. Okay. Now one more thing, while creating a VM virtual machines, don't use mouse too much. Play with the keyboard. If you try to use mouse too much, you'll have a problems. Okay. So let it come. From now onwards, I will use keyboard. Now what language? Keyword I am inserting enter. This is done. Yes. You want to connect with the network and enable the network? Yes. Done. What is a proxy address? If you are behind the proxy, you can set it up. Not needed. Done. Do you have a mirror address? Let it be same. Done. And do you want to, this is important, okay? Do you want to update the operating system with the internet, or do you want to continue without updating? So don't update with the new installer because it will consume lots of time. Okay. And I don't have a, I don't want you to spend, I mean, I don't want to spend right now 1.5 hours for doing that. So go for the without updating. So that way it will be faster. Mind it. Others will stuck for 2 hours. Now here, more or less, whatever is there, let it be default. Don't check, don't change anything. You can use the tab button to go to the done. Okay. Again, read it slowly. You will get comfortable. This is the file summary which got created. Done. You want to customize it, definitely you can do that, but right now not needed. Okay. So here, are you sure you want to continue? Yes. What is your name? So my name is Rajesh Kumar. What is your server's name? Server names, what you want to give it? Like a Linux training I'm doing, so Linux. What is your username? Rajesh. What is the password for Rajesh? Rajesh 123. Rajesh 123. Done. So this is the user. Mind it, each VM you create, you'll have one default user which is called root user. Okay. So mind it that you can sudo it using first you log into Rajesh, and after the sudo to the root you can do that. Okay, do you have some advantage token from Ubuntu? Not required. Done. Now guys, this is the most important one, and I have seen in the last batch also, last few batch, people are struggling because of this issue. What happens when you want to, after the creating a VM, you want to connect to the VM, SSH server was not there because you forgot to check it, and because of that you have to separately install apt get installed up, and you have to do that. But if you check it, you can save your time. So just go here and press wait, press space keyword, automatically it will be selected. That means open SSH will be installed and done. Now these are the extra software. If you really want to install, check it and then you can do that. But right now not needed. You can separately also install it and done. And now your system is being configured. Did you understand that, all of you?
Yes.
All of you? Now something similar you have to do for CentOS also. So let me show you for the CentOS also. So I'm creating a new VM, CentOS. Automatically it has selected Red Hat 64, which is because CentOS is from Red Hat. Next, I'll give 2 GB RAM only. Next, 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 next. 8 GB is okay because right now I just want to use for testing a demo. Create. And then click here, go to setting, go to the storage, click on this, click here. CentOS 7 is already selected minimal version, which I downloaded earlier. Okay, click start. That's all. Now here widgets will be little different compared to Ubuntu. So you have to do with the pace again. Don't use the keyword. Use the don't use the mouse. Do use the key. So here install CentOS. Yes. Enter. use the keyword always. Continue. I highlighted the through the tab button. Enter. Now here little confusing. You have to wait for a few seconds and go for installation destination. Remember that it's highlighted. Little confusing, but go to the installation destination. Whatever I'm saying in the recording, you have to do that for now. And installation destination, hit it, enter. And here just don't change anything. You see that keyword is highlighted to the done. Enter it. That's all. Nothing, no need to change. And you see that your keyword has been gone to begin installation. So if you want to play with the keyword again, you can do that also. And begin installation, enter. Now it's installing in the background. Meanwhile, if you want to change the password, use the tab button and change the password. You want to create a root. This password is for root. Okay. So Rajesh 123, Rajesh 123, and done. Now you want to create a new user, you can do that, and this is the way you can install your CentOS also. So I have installed, created a VM, which is Ubuntu is completed. You see that install complete, and then it has taken a update actually. Okay, installation is complete, but I want to cancel the update because update will consume lots of time. You can do offline, but I don't want to do that. So I cancel this update and installation complete. Your VM is ready to use it. Let's go to the CentOS meanwhile, and you see that either bar is showing you the installation process and so on. Okay, so now it's done. It's rebooting the stuff. Let's wait for it. CentOS is almost done, 80% maybe. Any questions so far, guys? All of you? Hello?
Good question.
Okay. So meanwhile, it is getting ready. Let's talk about some other topics also. So here, you need to understand how we can connect to Linux. Okay. So let's say this is you. This is your laptop. And from here, you have one VM you created in the same machine. That is a different server. Okay. Understand that each individual machines is separate. So this is a one machine you created a VM, which is actually inside the same here. Some VM you created. This is also one machine actually, kind of it. Virtual machine we call it. So how do you, this is you, how do you connect to this machine from here? This is you inside. How do you connect to this machine? How do you do that? So this connection you have to use through the networking. Okay. So what is happening? There is a protocol which you call it SSH protocol. If you want to connect to Linux machine, you need SSH protocol. For example, if you are accessing the website, HTTP protocol. If you are working with the FTP protocol. So same way, when you connect to the Linux machine, SSH protocol. When you connect to Windows, RDP protocol. So there is a different protocol for the network over which you can connect to the different machines. So here, for Linux, connecting to the Linux, you need SSH protocol. What is the default port for SSH protocol? Anyone have idea?
It's 22.
22. That's correct. 22. And Windows Desktop Protocol, anyone remember that?
Yeah, it's 3389.
Something like that. Yeah. So remember that different protocol is there for different devices to connect over the network for networking protocol. So now, in order to connect, so what you need IP address, what you need port number, what you need username, what you need password. These four information you need it. Now here in Linux, instead of password, you can have a key also. Okay, key. So password or key, IP, port, username, password or key. So right now I have a password, no key. But when you go and create a VMs on AWS, they give you the key, not to give you the password. You can enable it password also after this. I'll teach you in AWS session. Okay. So now you need all these four information. So that is one thing. Now one prerequisite SSH to work. Okay. One prerequisite SSH server has to be installed here. Mind it. Did we install the SSH server? Did we?
Yes.
In these two VMs? Yes. So in Ubuntu, I had selected it. I had selected it. So, okay, I had to click. Why is taking time? Okay, so I'll just go and reboot these machines. Go to here, shut down and restart it. Okay, and let me check the Ubuntu CentOS. CentOS is also done. So reboot, enter, done. So both VMs got ready, CentOS and Ubuntu. So here open SSH server should be installed here, and the client SSH client should be needed here. Mind it, client. So server in Ubuntu I installed it separately, but in CentOS they install it automatically. Don't need to install in CentOS. Mind it. So that's the reason you can understand. So there's some failure for Ubuntu. I don't know what. Let's see that. And CentOS power off and power on. Ubuntu. Oh, I think it has taken again. Not sure why. Maybe I cancelled the update because of that. Same option. Why is taking new? I did it one more time. Let it happen. Okay. So meanwhile, let me see that what is update for CentOS. CentOS I think is got ready. Let me check. Huh? CentOS also got. Is there some problem? Just a second. Let me check. Strange actually. I'm repeating the same step again. Okay. So let me do that. Not sure what was the reason for this, but we'll figure it out later. Again, same step, nothing difference. This is not required, but still I am doing it. Okay, there's some problem with the disk. So what I have to do, let me power off. Let me delete this. All data, delete all files always. Let me create new one, send to us quickly. 2 GB RAM. Same step. I have to create one more time. I wanted to increase the storage. Go for 20 GB. Go for same process. Send to us. Okay. And start this. See, it's downloading something. I don't want to cancel this time because last time I canceled, it created a problem. So let it be complete. It should not create a problem, but something has happened. Same thing I'm doing. In the CentOS, I think it was some disk issues. Continue. Tab, I can use it. And done. Begin installations. Begin installations. Set the, use the keyword always. Keyboard. Rajesh 123. Rajesh 123. Done. Yeah. So let it get it installed. Here it says install complete, but it's okay. Okay, so now, so I was discussing about, yes. So SSH server should be installed in CentOS. It automatically is there and started. In Ubuntu, you have to select it. Now SSH client should be there in your laptop and along with IP address, port number, username, and password or key. So these are the things required. So let me see that. Why this? Hmm. So done. Okay, so almost is getting ready. Let it be. Okay, one more thing, guys. Can you see my cursor is not going out of this console? Can you see this problem? All of you?
Yeah.
So this problems you will have while working with the VM. So when you click by mistake also inside that window, you will lose the cursor. So what to do in this case? So can you see what is written on top of the my time, date and time? What is written on my screen? All of you?
It's not visible.
No, on top of my date and time. Date and time is not visible. Downside,
Oh,
my date and time is not visible.
Right control. Right click.
Yes. Right control. That means why
Is
I
that
said
right control?
yes. So you have to remember this command always time.
Hello.
Right side of keyword and put the control.
Yeah,
So
Rajesh.
right
Is
side
it
of
right control?
yes, right control. Yeah. So if you want to release your cursor to your desktop instead of console of the VM, so right side of the keyword and click control and you got it. See, I clicked here, again got stuck, right side control. So always remember that while you will not have a frustration and something like that. So some techniques which will help you to do that. Now I'm thinking it's completed, but okay, so I'm not canceling it because last time I canceled it, it restarted the VM. I don't want to lose the time again. And here almost getting ready. So let it be. Let's get completed everything. Though install has been completed, it says on top, but something I mean not expected which has come. So now after this you will get a VM. So let me have one more VM which you can see here, Ubuntu 20. So this was already configured. So I'm going to reduce this RAM because I'm having limited RAM actually. Oh, this is not a VM. Let me check. No, this is delete. Let's have one VM which is here, demo for weekends. I think some weekends I might have used it. So start this. I'll set the only 2 GB RAM because I don't have too many things. So go for RAM. So 4 GB, right? 2 GB I'm allocating. And okay. Okay. So now I'm going to start this. Hopefully my system will not stuck. Let me close some of the applications. I'm closing some of the applications just to save memory. Okay, so third VM which was ready already and started it. Okay, this is the Ubuntu VM. So guys, it is asking me username and password. So what should I give it? So I think username would be Rajesh only, I guess, and
if you
password
can zoom,
Rajesh123.
if you can just zoom in, I think.
No, the problem is this it's max actually. This is good. All of you.
Yes,
Hello.
Rajesh. Yeah.
Okay, so I
Yes, Rajesh.
logged in. You see that here I have logged in, and now I can work. But you know what? I'm working in the console itself. Mind it, inside the VM. I mean, you are just like you're working in your Windows laptop, just like you are inside a Linux VM. But this is very irritating. Copy paste and from the browser and all, it's very irritating. So what do we do in this case? So I'll use putty. So go to putty. This is the one. Okay. So this is the putty. Uh, there are lots of clients are available. Putty is not the only one. So if you go for this blog and you just type SSH client, enter, and here, see here. list of free tools for SSH client. So many softwares are there. So here you have a Putty connection manager, Super Putty, MOVA, M Remote NG, and many are there. Whichever you are comfortable, go for it. But Putty I am using for this training because if you're starting it, Putty is the best tool actually. Very lightweight, very lightweight. Okay. So how do we download the Putty? So I think in the same place, if you write a download Putty, you'll get the right tutorial for it. And here you can follow this one and get it done. Okay. So Google also you can do that. So that's not a problem. So you can download the Putty and then done. So I have a Putty and here I have to give the IP address. Now what is IP address? So I'll click here and IPA will tell me IP address. What is IP address? 10.0.2.15. So I'll come right side click control and come out of it 10.0 10 dot what 0 whichever you see ENP0S3 kind of it, that will be IP address. So 10.0.2.15 and here. So it's not connecting. So what to do? So I'll troubleshoot and I'll ping this. So ping 10.0.2.15 and you're not able to ping. Ping is basically to check the network connections. So that means my desktop cannot reach out to the VM through the network. What to do? So basically what happens when you create a VM, mind it guys, when you create a VM, okay, so this CentOS got completed. So let me reboot this stuff. Hopefully this time you'll not have a not surprise. Right click control and let me see the Ubuntu. This is really irritating me. I'm not sure what should I do now. If I cancel update and reboot, it should not be. So I'll let it be. Let it be actually. Okay, just 5 minutes. Let it be. It's not impacting our work. So let it be. Okay. So now what I what I did, networking is not accessible. So what is happening actually, guys? Mind it. When you create a VM, the default networking, if you see, is here NAT under the networking tab. NAT. So NAT is a one of the networking driver which is not allowing direct network connections to the VMs because of the protocol. I'll not get into that complexity of NAT and types of different drivers, but NAT will not allow. Bridge, there is other bridge, host only, and many things are there. So I would suggest you spend some offline times. I'll create an assignment also. What is a NAT? What is a bridge adapter? By the way, let me tell you, these are not the VirtualBox training. I mean, such topics. Anywhere you go, any technologies, you have to work with a NAT, bridge, host only, generic, and all stuff like that. So you should know that. Okay. So NAT will not allow. So just to avoid confusion, you have to go to the bridge. Bridge means what will happen? Your VM will use the same network what your laptop is using. That means I'll put it in a picturization way so you'll understand this. Bridge will allow, this is your home, okay, and this is your router. This is the bridge, and this is your one laptop. This is your mobile. This is another laptop, and inside that, what you did, you created a one VM, one other VM. So now, right now, theoretically, what is happening right now? This VM is connecting to this router. This mobile is connecting to this router. This laptop is connecting to this router. This laptop is also connecting to this router. So all of you are getting the internet networking and internet from this router, and this is connected to your home. Now this VM because they created one smaller network NAT, so you are not able to connect from here. So what to do? So I change the networking type. Now this VM also connected to this network. So this is called bridge network. Are you understanding, all of you?
Uh, yes,
Yes.
Rajesh.
So I'll click change the bridge mode. Mind it, these all things which I'm doing is important. Rest of the things you'll do figure it out. I just change this. Now if I go and check it out, guys, if I go and check it out, IPA, see earlier, if you remember, the my series was starting with a 10 when a NAT was there. But when we selected the bridge mode, it become a 192. Now if I want to show you the my IP address also, and if config, right? No, IP config in Windows. See, this is my IP address 192 series. You see the VM also has the same one. So now if I try to connect it to new session 192.168.1.2, right? 2, 2. Accept. And see, they're asking username. What is username? Rajesh. And this is a password 123. Done. Now this is the Rajesh user, and you can I can change the display also so you can visualize better. Apply. Hope it is visible. Correct? Huh? And now this is your Linux box which you are connecting from your Windows to the VM. Do whatever you want. It's CentOS version, is Ubuntu version. You want to become a root, sudo -s, and then Rajesh 123. Done. So guys, your VM is ready. Now let me check if some VMs which we created can we access. Yes, here is Rajesh. Is sent to us. Rajesh 123. Same thing you can do with the same VM also. Rajesh 123. No, okay. Rajesh. Oh, sorry. It's a sent to us. I did not create Rajesh in that. So it's a root actually. Mind it. So root. Yo, root Rajesh 123. Got it. Now let me check the Ubuntu also. This is really irritating me, but I'm okay. Now it has come reboot now. So I'll just reboot now. Earlier it was updating and reboot. I don't know why it was taken updated, but it's okay. So I'm rebooting this Ubuntu also. Same way. Convert into the bridge mode, get the IP address, connect to it through the putty and start working on it. Did you understand that, all of you?
Yeah. So is there no key required here? I think.
No. You can generate a key using SSH-keygen and you can enable the key. That is not a problem. But right now default because the VM password enable. So Rajesh, what is a username? Rajesh, right? And password Rajesh 123. Ubuntu also you got access. Here also you become a root sudo -s Rajesh 123. You become a root now. So guys, now don't depend on someone else. You have a laptop. I'm assuming everyone must be having at least 16 GB. Okay. And my manager is having 32, no, 64 GB actually. They should give it to me 64 GB, but he's having 64 GB laptop. So yeah. So create a VM, server edition, mind it, it's consume little less CPU and RAM. 2 GB you can allocate, 3 GB you can allocate and start working on it and do whatever you want. And then after the work, if you want to stop this, just click power off. And this setup will be there for your local. no need to pay to AWS. Same thing AWS will do and charge you for it.
Yeah,
Understood,
so
all of you?
in this case, if we are reserving a RAM, right, is the RAM gonna get logged into this, or is it gonna get free after it is powered off?
Power off, after that it will be free, no? It will be free.
Acha.
That's the reason I powered it off. Okay, any questions so far, guys? All of you?
Yeah, Rajesh, can we get this image, any shared location so that directly we can use your downloaded image?
You can download from the internet. No, it's a just type in Google, you will get the direct link.
Yeah,
Why to
yes.
why me to down why me to upload you in some place from there you download might be slower. Directly download from the source, it will be faster. I'll share the location in that.
Oh,
Okay. Any other questions on the virtualization part, guys? All of you understood?
Have any issues with our channel membership, you can drop an email to us at contact@devopschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest.
Thanks for watching.